A man rows downstream 32 kilometers and 14 kilometers upstream. If he takes 6 hours to cover each distance, then the velocity in kilometers per hour of the current is. Now, in the topic of boats and streams, we need to know the basic assumptions. So, the basic assumptions are we assume A as the speed of the swimmer or the ship or the boat in still water. B is the speed of the water body. Upstream speed is A minus B and downstream speed becomes A plus B. Now, it is given here a man rows downstream 32 kilometers, but this is not the speed. This distance is covered in 6 hours. So, to get the answer of this in 1 hour, it becomes 32 upon 6. So, downstream speed becomes, that is A plus B is equal to 32 upon 6. The reason we are dividing it by 6 is we want the velocity in kilometers per hour. So therefore, we get the speed of the man downstream speed. So we know speed formula is distance upon time. So the distance here is 32 and the time is 6. And that's why we get this equation 32 upon 6. Similarly, A minus B will be equal to, again by applying the same formula, the distance upstream distance is 14 and the time is 6 hours. So it will become 14 by 6. So these are the two equations we get from the given data. Now the question asked is the velocity of the current. Current, that means it's a water body. So that means we have to find the value of B. When we have to find the value of B, we need to subtract the second equation from the first. So this becomes minus, this is plus, and this is minus. So A minus A, it gets cancelled out. B plus B, that becomes 2B. And on the right hand side, you have 32 upon 6 minus 14 upon 6. Now, as the denominator is same, we can easily subtract. So 32 minus 14, that is 18 by 6. 18 by 6 is 3. So we have 2B is equal to 3. So therefore, B is equal to 3 by 2 or 1.5. So this is our answer, option C.